Today we're going to discuss about Lagrangian and Eulerian description in doing mechanics. First, let me present our objectives. The first objective is explain the difference between the Lagrangian and Eulerian methods of analyzing fluid flow. Next, demonstrate the practical example of how each approach is used in real-world fluid mechanics problems. After that objective, let's present you an overview of our lesson. Lagrangian approach focuses on tracking individual fluid particles as they move through space and time, similar to following the path of the specific object in flow. On the other hand, the Eulerian approach examines a specific point in space and observes how fluid properties like velocity and pressure change at each location over time.
So, for further information about Lagrangian description, let me read first. Lagrangian information concerns the nature and behavior of fluid parcels. So, in Lagrangian description, it focuses on individual particles that tracks the position, the velocity, and other properties that individual particle over time. So the Lagrangian description uses particle paths. These paths used to understand the fluid's behavior. In Lagrangian description application, they uses individual particle behavior, which means that this approach is excellent for understanding how specific particles move and interact within the fluid. So in EULERIAN, here Ms. Haslyn to give you more information.
Let me discuss the EULERIAN. EULERIAN information concerns field properties like velocity, pressure, and temperature that vary in time and space. In the EULERIAN description, it focuses on specific points in space and observe how fluid properties change at those points over time. In a certain fluid, when it flows, tinitingnan niya kung ano yung bilis nun kapag in a period of time. Rather than tracking individual particles, it studies the flow field at fixed location. For example, imagine standing on the bank of a river and measuring how fast the water is flowing at a particular spot. The EULERIAN method is like placing sensors at different points in the water and reporting how the speed, pressure, or temperature of the water changes as it flows past this fixed point. This method is commonly used because it makes it easier to model large fluid flows and study how entire regions behave. Usually ito ginagamit like sa air movement sa atmosphere and yung water circulation sa ocean.
The difference between the Lagrangian and Eulerian description. Lagrangian description follows the motion of the fluid particles, individual fluid particles, while the Eulerian description observes the change at fixed location over time. Each method offers the different perspective, and depending on the problem, one may be more useful than the other. Both descriptions are essential tools in understanding and modeling the complex behavior of the fluid in the natural world and in the engineered system.
As for the example, let's use this problem. Water flowing through a pipe. In Lagrangian approach, imagine you release a small drop of dye into the flowing water. You track the dye as it moves through the pipe. This method tells you how the drop's position, speed, and other properties change over time as it flows with the water. While the EULERIAN approach, instead of tracking the dye, you pick a specific point in proper place at that fixed point over time, observing how the flow behaves at that location without following individual particles. In these examples, it says that the Lagrangian description is